So if you notice, permanent dipoles come about when we have polar compounds. So the temporary ones are going to come from non-polar compounds. The person that just asked that question, the answer is no, the same thing. When we say dipole, it's just referring to the interaction between the two dipoles from separate molecules. So it's not different. All right, so these arise from nonpolar compounds. All right, so for this one, this is how we explain it, right? So let's say you have chlorine, Cl2, all right? And I'm going to use a diagram to explain this. So in a molecule, the electrons are constantly in motion, all right? So the proposed explanation for this is that the molecules, sorry, not the molecules, the electrons are constantly in motion. So if there is random movement of electrons, then at some point in time, right? So let us say after, and this is just for explanation purposes. So let us say the molecule started out like this, right? After 50 seconds, we have more electrons to one side of the molecule, all right, than the next. It means that the side with more electrons or the higher electron density, it will develop a slightly negative charge. And the side that is electron deficient, it will have a slightly positive charge. So as you can see here, we have a dipole. But remember, the key thing here is that the electrons are in constant motion. Unlike the permanent dipole, let me just do that again, right? When you have oxygen and hydrogen, the oxygen pulls the electrons closer to itself. The electrons are going to stay there. They are not moving back away from oxygen. That means this stays slightly negative, this will stay slightly positive. So it is permanent. With this one, the electrons are going to be moving. So when the electrons move from this side and come over, you can get back this initial diagram here. So let us say after 90 seconds, it goes back to looking like this, where the electrons are evenly distributed. So if you look up here, so we started out with no dipoles. After 50 seconds, more electrons were to this side. So it developed a slightly negative charge, and this side developed a slightly positive charge. But so we got a dipole. But this dipole is not permanent, it is temporary. So we get our temporary dipole from the random movement of electrons in nonpolar compounds. All right, so that's temporary dipole. The next form of dipole I must explain is induced. All right. Now I'm going to put a neutral molecule again. All right. So this right here, we were just looking at what happened to one molecule. So let us look at a second one now. If it comes close to the negative end of this one. So again, you would have the electrons being evenly distributed. All right. Now, if it comes close to this negatively charged end with the surplus of electrons, there will be a push on the electrons here, repelling them. All right. So what is going to happen is that these electrons at this side, they are forced down to this end. All right. So before the molecule was neutral, no charge. The excess electrons here pushes the electrons down to this side of the molecule. All right. So what that means is that we will not have a lot of electrons at this end. All right. So I'm going to leave one up there, but I'm going to put most of them to this side. So that means this side will develop a slightly positive charge, and this one developed a slightly negative charge. This one, yes, I am explaining right, but it is van der Waals forces. But to get to van der Waals forces, you need to understand how we get temporary dipole and induced. All right. So the temporary dipole. All right. So remember for this, so I'm just answering a question that was texted. So the surplus of electrons at this end of this molecule is repelling the electrons from this molecule when it gets close to it. So right here we have electron repulsion. So the molecule, the electron in this one is pushed to the next side. So once you have a great amount of electrons to one side, that is when you get the negative charge. And on this side, it is electron deficient. Right. So the reason why we use the term induced, it was not a natural dipole. It did not form randomly. It was forced. So because it was a forced dipole, we say it was induced because it was due to the repulsion of the electrons to one side of the molecule that created this dipole. So it was induced. All right. Now, from what you have been seeing with intermolecular forces, right? Once you get a slightly negative end close to a slightly positive end, there will be an attraction. And we use broken line to show the attraction. So this attraction between the negative end of a temporary dipole and the positive end of an induced dipole, that is the van der Waals force of attraction. All right. So this attraction, so this right here, this attraction, that's van der Waals. And it is the weakest one.
But sir, isn't this like always breaking, always forming?
That is correct. I was going to mention that as well. So when you have it here, sorry, give me a second. Van der Waals forces. I'm just making a note that it is the weakest. Now, if you go as the person said a while ago, right? they are always breaking and reforming. And the reason for that, remember that the electrons are always in motion. So the electrons here, right? If they should move over, will we still have the negative charge here? Anyone want to offer an answer? If the electrons, if the surplus of electrons,
No, sir. No, sir.
right? Because if the electrons move, then you cannot have the negative charge here. The reason why we got the negative charge here is because there was a surplus of electrons. So if they move over, the negative charge moves, or it's gone now, and so you will no longer have that attraction. So as you said, it will break and reform. Let me see this person. Right. All right. So let's just go over van der Waals, right? First, it occurs in nonpolar molecules. The electrons we say are in constant motion. So at some point in time, you will have a surplus of electrons to one side of the molecule. When that happens, that side will have a slightly negative charge. The other side will develop a slightly positive charge. All right, and that is your temporary dipole. So temporary comes from the random movement of electrons. Now the induced dipole is when a neutral molecule, that is, it does not have a dipole, it approaches the temporary dipole. All right, we will have electron-electron repulsion, right? So the electrons now are pushed to one side of the molecule, causing a dipole. Now this dipole was induced due to the electron repulsion, all right? Then now what you will have is the interaction between your temporary dipole and the induced dipole. That interaction is van der Waals forces, and it is the weakest one. All right. So induced dipole is not the same thing as temporary. No. So remember, temporary, well, it is still temporary but in terms of how it came about. So the temporary, it was came about because of the random movement. So let me just do this one again here. So there's a little difference between the temporary and the induced. This one is just about the random movement. When the neutral molecule came here, all right? Remember, it came without a dipole. All right, so let me just put in some electrons. All right. So when it came close to the negative end of this molecule, the electrons here, the surplus, was pushing against or repelling the electrons in these. So it pushing them further down into the molecule. So the electrons are being pushed to this side. So it was not a random movement, it was forced. So because it was forced, we say it was induced. So when the electrons are forced to this side develops a slightly negative charge, and this one develops a slightly positive charge. So this one was induced. This one was random, so we say temporary. All right, hope that was a bit clearer. All right, so let me just move the electrons down. All right. All right, so let me put it in words for you. All right, so you can have it to read.